And so we have here is another limit that we're going to evaluate analytically, which again means using algebra and not graphs and not tables of values to try to evaluate the limit. So in this case, just notice again, if we substitute x equals 6 in the numerator, which is the item in parentheses, we get 0. And in the denominator, we get 0. So here again, this is a clue that maybe there's more we should do to manipulate this expression. So the first thing that comes to my mind is, hey, we have a complex fraction. So that means I'm going to multiply by the lowest common denominator between those two, and that happens to be 6x. So I'm going to multiply the numerator by 6x, and I'm going to multiply the denominator by 6x. And remember, that's multiplying by a form of 1. So all we're doing is changing what the expression looks like, not really what it is. So this is the limit as x approaches 6. Now here we have 6x times a quantity, 1 over x, minus 6x times 1 over 6. So that to me looks like 6 minus x all over. Now the denominator, since the goal is to usually remove a common factor, I don't multiply out the denominator. So I'm going to leave that as 6x times x minus 6. And this is looking a lot nicer. One little thing that we need to do in the numerator, though, it looks like, is factor something, because the 6 minus x looks kind of like x minus 6, but not quite. So I'm going to factor out, well, the first thing I'm going to do is write this in descending order. So I'm going to call this negative x plus 6. When I factor out a negative 1, I now get x minus 6. And that's the key to this problem. So now at this point, the x minus 6, the culprit that's making all the zeros happen, goes away. So now I have the limit as x approaches 6 of negative 1 over 6x. Now it's safe to substitute 6, which means I have 6 times 6 in the denominator, which is 36. So that limit is negative 1 over 36. And just notice, if we had used a table of values, it would have been really hard to come up with negative 1 over 36 since we had all those decimal values there. So this is why we use the algebra, because we get exact answers. So hopefully this helps. Hopefully this made sense, and watch out for more videos. Thanks again.